Alright, so hey guys, it's the next morning and we're gonna be trying to speed run through the last 3 example questions and then so that we can get to the tutorial questions, okay? So for this example question, you can read it yourself first, it's on the screen. It's example 5 from the 2010 CMO. So it says that two circles intersect at A and B as shown in the diagram below, but I didn't provide a diagram because I wanted to draw it out. I find that if I drew it, it would be a bit better because the diagram that they provided is very small, compact, and not that easy to understand. So a line passing through B, okay, first of all, let's just draw the two circles out first. They said two circles intersect at A and B, so let's just draw. Wait, it's not working. Okay, so A and B. Line passing through B intersects R1, R2 at C and D respectively. First of all, let's name this R1, R2. So a line passing through B intersects at C and D respectively. Another line passing through B intersects these two at E and F respectively. So it can be something like this. Put up the line and start off at B. So E and F, okay. The line CF intersects R1 and R2 at P and Q respectively. So CF, we have P here, Q here. Let M and N be the midpoints of arcs PB. So PB, so M is here, N is QB midpoint, okay. Prove that CF and N are concyclic if AD equals EF. So we have one free condition, which is CD equals EF. They're asking how are we going to use this one free condition that they give and deduce until the point that CF MN concyclic. So this is what they're asking. Of course our working is not just like this, okay? We have to work step by step and go down. So let's just draw some helping lines. Just connect everything that we think need to be connected. It looks like the N is not that nice. So N should be here instead. And okay. I think that's almost all that we need. Yeah, okay, let's just work with this. So first of all, we know that angle ADB equals angle AFB, right? So this is equals to this because of wait, I missed a line. So they're saying that ADB is equals to AFB because of this. Oops. Here, angles in same segment. Okay. And angle ACB equals angle AEF. So this one, ACB, is equals to AEF. Why? It's quite easy to see. ACB, right? Then what is this angle? This angle is 180 minus ACB. Then what is AEF? AEF is 180 degrees minus this angle, which then you get like ACB. So that's why it's equal. So having all three of this condition, we realize that, let me just mark it out for you. We have CD equals EF. Okay. We have ADB, the angle ADB equals to the angle AFB. And angle ACF equals angle AEF. So ACB angle equals to angle AEF. So what do you see here? This just shows that triangle AEF is similar to triangle ACB. Okay. And it's not only similar in this case, it's congruent, because CD equals EF. Now this tells you that AF equals AD. The sides, we match the sides here. So AF and AD are equal. So what does this mean? This means that here and here is equal. That means this angle and this angle will be equal due to isosceles AFD. So angle AFD equals angle ADF. Okay, and now you have to notice that, okay, not implies actually, angle ABC, right? So angle ABC, this one, is equals to angle AFD. Okay, which is also equals to angle ADF. So ABC is equals to ADF. Which is also equals to angle ABF. So ABC is equals to ABF is equals to this one, so AB, the line AB is angle bisector of angle CBE. And we know that FN is angle bisector of angle CFB, since it's the midpoint of the arc, and CM is angle bisector of angle FCB. So now I want you to switch your focus to this. Do we have any more colors? Okay, I'll use purple one. To this triangle CFB, and you realize that you have 3 angle bisectors. 1, 2, 3 of its 3 angles. So they should intersect at the in-center. Okay, so my diagram is not the best, but they basically intersect somewhere here. The in-center. Let's call this I. So intersect at I. And I lies on AB, which is the radical axis, and you can see that CI times CM would be equals to NI times IF, which concludes that CF MN CFMN, yeah, are concyclic. Because basically what setup that you obtained is a circle CF M N and Oh, sorry, wait, I just realized I wrote something wrong here. Times IM. So basically, this statement is saying, why does this statement prove that CF and N are concyclic? Because Ci times Im equals Ni times If. That's why it proves that it's a concyclic, and we're done. So that's it.